Before we get into specific sorting algorithms, I want to talk about a few of the prerequisites here for some of these simpler or sorting algorithms we're talking about. That'll help us guide into some of the more advanced ones, some of the more complex ones. So when I say simple, it's not that they're easy. It's not that they're super ridiculously. I mean, they tend to be slower, but mostly what I mean by simple is that they're easier to visualize. That you're going to be able to have either some real world analog or it's very close in that you'll be able to see the algorithm at work. Some of the more advanced ones we're going to talk about later on often are using very creative, clever solutions that don't have any real world, you know, analogy that goes in that. It's not a way you'd manage a warehouse. It's not a way you'd solve problems traditionally. It's just a very clever algorithmic slash mathematical way to speed up and reduce the number of operations recall. So one of the keys to programming, um, we talked about this with recursion, but these sorting algorithms as well is you have to remember we have to think like a computer. So we have all these horses here, and all these horses you can see have blinders on because we don't want the horses. Well, one of them doesn't, right there in the middle, but many of them do because we don't want them staring at each other. We don't want them seeing somebody coming on this side and getting spooked. Well, as programmers, one of the toughest things to do is remembering what we can't see. When we're working in the algorithm, we can only see certain aspects of what we're working on. Algorithms can't know that when it looks at the next item that the three down from there is actually lower. As a human, we can look at a list of numbers and pick up a lot of data. So you look at a billboard and you see 10 different items that pop into your mind at once, where a computer can only read one character at a time, one item in the row at a time. So it's important to remember that as you're looking at the data that this you have to think algorithmically, one little step at a time. And so we can actually in all of these sorting algorithms test super easy because the test is as simple as saying, hey, as long as each item is greater than the one before it or less than the one prior to it, vice versa, whichever way you're looping through, then your list is sorted. So if we look in the middle of this list, we have a situation where O is greater than N or N is less than O, and so this list is not yet sorted. So all of my test cases are really super simple. I just when I send you a list, an array, and you sort it, and it comes back. I just loop one to the end to make sure every item is less than the next item. And if that's true, then it's sorted. So from that standpoint, unlike some of the code we've written up to this point, the test cases are ridiculously simple, but the algorithms have a lot going on. There's sometimes thousands of steps that's happening to sort what some of these lists. So it's going to be important to you to understand how to debug your own code, to use print lines as appropriate, to manage the test cases from the number of things that are being generated. There's two different types of tests that are out there. We'll see that later on. And so just if you're really complicated, keep it down to small lists until you get it working and then jump those numbers back up. So just know you have some control here, but the validation is super easy. Now, the code I'm going to provide to you also has some helpers, and it's important to understand these helpers. You don't have to use them. You can use this code directly, but it will help align better to the different algorithms you see in the various books and resources online. So the first is there's a helper for comparison that's often defined out there, which basically compares two values to see if the first one is less than the second one. And it's important to remember the ordering of those in the parameter because there's the books always refer to these as either less or prior or some different similar word, simile here of this concept. And so the code I'm going to provide you has these built in. You can use these if you so choose, or you can just simply use the greater than, less than, or whatever approach you want to for your code. The other helper inside of there is a helper for moving values back and forth in the array. Now, it could be two things next to each other or two things completely apart from the array. It's basically off of, in an array, two indices that's going to be swapped. And so this is either called swap or exchange in the various different texts out there, or something along those lines. But that essentially is just creating a temp variable and assigning the temp variable, moving one value into the other, and putting the temp back in the other. So it's just basically a simple swap. But these helpers will show up in the book algorithms and in algorithms you'll find online. And I have given you this within the code that you can use if you so choose. So the other thing that's really important to remember is you are expected to be exchanging in place. So you will be handed an array, you will not return anything, that array will be changed at that location. So my test cases actually copy the array before they hand it to you. So the original array I have a copy of, and the one that you have is a copy of that, and then I have another copy which is the expected value, the final value right there. And so if you ever are confused in your code what it originally looked like or what's being changed, know that that original one is out there in the tester as well. You can always print it out to start with and see what the original value set looks like. But you shouldn't need to, because you can always print this as it comes in. You have full control over this array. There's no secret code behind it. Everything you change is directly changing the thing that the test code is looking at as well. So the first set of problems that we're going to look at this week, and the ones that you're going to see the start of right away. After you've looked at these, take a break, make sure you're coding these up before you go into the more advanced ones. But the first is going to be the bubble sort, which is really simple, not super useful. It's really slow, but it's conceptually important to see, as I said, what the instinct might be to do to sort things, and then how we can do better after that. So the next is the insertion sort, which is quite accessible as well, still kind of slow. And then we can talk about the selection sort, where we're starting to get really clever in our algorithm, but it's not quick at all compared to the last one we'll look at, which is the shell sort. The shell sort is not, the shell doesn't mean anything. It's not like a shell game or seashells. Shell was the inventor of this, the gentleman who came up with this algorithm. And so this is really clever way that builds upon the insertion sort in particular to gain really impressive speed overall. All right, so this was just a quick overview of some important concepts that might help clarify these algorithms going forward. I am going to challenge you to basically convert the code over for each of these in turn. I built every single one of these from the textbook, and actually I built multiple versions in looking at a couple different textbooks. When there was a variation, I built a couple different versions of many of these. None of them were too difficult. There was a couple little bugs just simply by typing in the code that was there, more or less. I had to make some tweaks, not too many, but mostly it was just me reading poorly or not paying close enough attention. So I don't necessarily expect that these are going to be immensely difficult, because most of the algorithms are fairly straightforward, but the risk is you might get it working and not understand what the heck it does. And so this next sequence of videos will hopefully help combine your activity of building code along with maybe seeing these examples and understanding what the code does. And so I can hopefully encourage you to really get a stronger, deeper feel for how not only to build these, but how these really work, and understand how they are a good algorithmic tool to be able to put in your future supply of inspiration for code.